So hey everyone, this is the video on SQL part 2 where we start from joins. Alright, so in the last video we had covered the part 1, which is only for those concepts that were beginner level. So this video onwards we are going to start with the intermediate level. Okay, so if you are a beginner, make sure you watch those videos before getting into the intermediate level. From here onwards we will have the prerequisite of having the basic knowledge. Alright, so you can just have a look at that video and then come back here if you are, in case you are a beginner. So let's get started with joins. Okay, so by definition, join is used to combine data from two or more tables based on a column between them. Okay, so let me just increase the size of this. So for example, like we have the two tables over here. For example, we have the customer table, we have the sales table. So the customer tables only contains the customer details and sales tables only contain the sales. So here we have the customer ID, and also in the sales table we also have the customer ID. Okay, so which actually refers which customer actually made the sale. Okay, so you see that customer 1 over here and customer 1 is also over here. So when we look up to the customers table with the customer ID 1, so the name is Alice and the city is Delhi. Okay, so this is how you can look up from other tables and then get the data who exactly purchased this item. Okay, so you might have a question like, why don't we actually populate this everything, all the customer information within the sales table itself? So that would be a bad idea because we are doing a lot of data duplicacy. Okay, let's say we have another table called as payments. Okay, so in the payments table as well we also need to include the customer details, so that details is also there in sales table. So that is why we only provide the customer ID and not the entire customer details itself. So whenever we want to look up based which customer actually made the purchase, then that is when we have a query to the customers table. So that is why we do not store all the data in one particular table, and we only store data in such particular table which are relevant, and only we just make a reference to that table based on a ID. Okay, so for example in this case it is the customer ID. So in some other table it might be some other key name. Okay, so this is basically called as data normalization, where exactly we need to plan before we start inserting columns into our database. So coming back to our basic question, so let's say this is the sales table. How can I know which customer actually made the purchase? So that is when we apply something called as joins. Okay, in SQL there are different types of joins as well, which we will come to it very soon. So the one thing which we notice is we have just the customer ID, and the customer ID is also there within our customers table. So we just need to apply the joins. So there are different types of joins which we actually need to know. The first and the most commonly used is the inner join. So basically this will only return us the records that are having matching values within both the tables. So for example, if I apply a inner join between customers table and sales table, I will only get those records that have actually matched. For example, Alice has purchased something, that's why we see the Alice customer ID, and also Bob, which is also 2, but Charlie has not made any purchase. So whenever we apply the inner join, so only we get those records that are actually matching. Okay, and also the same, the customer ID 5 doesn't exist within our customer table. Okay, so we don't get that particular customer, so we only get Alice, Bob, and we do not get the 5th customer that is not even there within our customers table. So that is what is inner join. All right, so there are multiple types of joins which we'll come across. So the syntax is very simple. So we just select everything that we want from the respective table. Like for the customers, it's the customer name and the amount from sales, just for example. Then we apply the syntax inner join and then the reference table. So this is, we are selecting from the customers, so we want to refer the sales table, and we just want to map the matching column. So just as I told, the matching column is customer ID, which is also present within our customers table. So that is what we need to separate them by an equal sign by giving the on operator. So on customers dot customer ID, and then map that to sales dot customer ID. So we just get all those records that are matching. So you see that this is the result. Since I have only selected the customer name and the amount, I get the customer name and the amount that the customer has purchased. Okay, so that is from here. So we see that 5,000, 2,500 and 4,000. So that is what we actually get over here. Okay, so you can just think of this in the form of a diagram where the first table is the customer and the next one is the sales. Only those that are matching, you see that only those that are intersecting, that records will be returned. Okay, so I hope this is clear. So now let's move to the next type of join, that is left join or left outer join also you can call. So these are all the things that are returned from the left table. So this is the left table, for example, and this is the right table. Okay, so basically when I show the diagram, so over here it will return all the rows from table A, and also those that are matching from table B, okay, and but not those records that are not matching from table B. So I know this sounds a little bit confusing. Let us understand a bit deeper. So by definition, it returns all the rows from the left table. Suppose if we are considering customers to be our left table, and then matching rows from the right table. Only the matching rows from the right table and not all, okay? But in the left table, even though if it matches or doesn't match, we get all the column, all the records from that, okay? If there is no match, we just show null. For example, if a customer hasn't purchased anything, so it just shows as null, okay? So the amount, for example, here it shows as null when we apply the left join. So the syntax is very simple. Instead of inner join, we say left join to the reference table, that is sales, and then we just do the mapping. So that is from customer ID, that should map the sales customer ID, okay? So that is where we get. So you see that now we get all the columns from the customer name, irrespective of whether the customer has purchased anything or not. So if we refer our customer table, so we get all the customers, you see, as you see over here, okay? And if they are not purchased, we get null. So Charlie and David were not existing within our sales table, so that is why we get null, okay? So I hope this is clear. The same way goes for right join. I hope you understood. Once you understood left join, right join is almost similar, as you might have guessed. So we only get all the records from the right table, okay? So it returns all the rows from the right table. This time it is sales, and only the matching ones from the left table, that is the customers, okay? So if no match exists, null is shown for the missing customer data, okay? So instead of left join, we say right join, and over here we get all the sales, okay? So in case that customer has not purchased, or it is an unknown customer, we just get null. As you see within this table, there is no customer with the ID 5 over here, okay? So there is no customer with the customer ID 5, so that is why we get null in this case over here, okay? So this is the diagram which you can understand. The next type of join is full outer join, okay? So this is the last type of join. So this is which basically it returns all the records from both the tables, whether they match or don't match. So if there is no match, the missing side shows null, okay? So over here you see that we just need to say full outer join, and then the reference table, that is sales, again we just specify the mapping, and in this case we get the result, okay? So in this result you see that there are some values on the right which are null, some values on the left which are null. So basically we get all, whether they are matching or not, okay? So within this diagram you see that we are getting all the data, but we don't get any other data outside this, okay? So everything that we have from our sales and customers data we get over here, and if they are not present, it just returns as null, okay? So I hope this is clear. So this is the diagram, and this is just a short summary which you can just have a look, and also I will be attaching this document within the description of this video, so that it can help you as a guide. So now let us go back to our actual database and then perform some queries, and then I'll give you a challenge question so that you can test your knowledge and then try to figure out how joins actually work, okay? So let's get started. So the database which we are currently using is pgadmin. So in the last video I already explained you how you can install pgadmin and also your SQL server. So in case you found stuck anywhere, you can just refer that video, and also I have explained how exactly you can seed some sample data, which the current database which we are actually using is the flights database. So I have shared step-by-step process in the last video, so you can just go ahead and import that data, so in case you want to follow along practically. So let us go ahead and log in within our database. So currently we are having 8 tables, okay, and the schema is also attached within the description of this video, which I can just display that over here. So it is right here. So we have currently 8 tables. So the main table which we are going to deal with is flights database, okay? So you see that these are all connected to each other by certain keys, okay? For example, within this flights table, the flight ID is linked with this ticket flights table by referencing the flight ID field, okay? So this is how you can look up into other tables and then get data from there, okay? So that is what exactly we are going to do. So we are just going to have a look at the ticket flights table by joining the flights table and then having a look at all the columns, okay? So let us go open our query tool. So we can just right click and open our query tool like this. So now we can just say select star from flights. So basically we have our flights table, right? So with all these particular columns that are also mentioned within our schema right here. So now we just want to make a join to the ticket flights table. So we can just say inner join, and then specify the table name, that is ticket flights. Okay, so here we just want to specify the mapping condition on. So basically the ticket flights, we can just give this a alias of tf, for example ticket flights, and for flights we can give it as f, like this. So now we can just say tf dot, we just need to like map the primary key and the foreign key. So basically primary key is the one which the table which we are actually querying, and then foreign key is the table which we are actually making the lookup. Okay, so from the flights table is our primary, so you see that this is the primary key, that is flight id, and we just are looking up within the foreign key, that is the flight id. So you see that it's marked as fk, which stands for foreign key, and pk is the primary key. Okay, so that is what we are doing here. So tf dot flight id, so you can just refer the exact name, flight id, sorry, f dot flight id equal to tf ticket flights dot flight id. Okay, so now if I execute this, so you see that I also get all the columns even from the ticket flights table. So we get even the fare conditions and amount over here. So you see that we getting fare condition and amount. So only those columns that are actually matched will get, since we have used the inner join. So in case I just want to specify certain fields and get those values, so we can just say select f dot flight number. Okay, since we are giving this flight table, and then the ticket number, for example from the ticket flights table, so we have the ticket number here, so that is coming from the ticket flight, so that is tf, which the alias which we are given here, dot ticket number, and then we want the amount, for example. Okay, so now when I run this, so you see that flight number, the respective ticket number for that flight, and then the amount. Okay, so all these columns were not there with from our flights table. So if we have a look, it's right here, so you see that the amount and the ticket number is not within our flights table. So we had made a lookup to our ticket flight, so by joining, and then took the ticket number and amount. Okay, so this is how you can just perform joins. So currently we have like about 1 lakh records. So this is just by using inner join. So let us now apply the left join and then see what is the result. So when I play this time I should get more records. Okay, so it was slightly more than the previous one. So whenever we are applying like left join or right join, we always get more records, just as I showed you in the diagram. It also includes columns which are not also matching. Okay, so here this is the left join. So if I just say like put a condition here where the ticket flight dot flight id is null, so I will also get null values over here, just as you see over here. So the respective flight number does not have any ticket number nor amount. Okay, so this is when we apply the left join. So the same you can also test for right join as well. So if I just say right join, so now I don't even get, because we are getting all the columns from the right side, right? So there is no null value. So here is a challenge question for you. Find all the flights that are having tickets costing more than 80,000. And the second question is to retrieve all the airports and any flights that are departing from them. Okay, so if you have understood the joins concept, so you can just go ahead and give it a try. Okay, so I'll just go ahead and write the solution for you. So when we have a look at the schema over here, so we just need to return the flight number, and then we need to also return the amount, okay, which is in the ticket flights table, which is greater than 80,000. So we just need to apply the join just as we did before. So let's go ahead and do that. So first thing is we want to say select first thing is the flight number, so and then we want the amount, so we say amount from flights. So we can just give this a alias f, so just to distinguish which exact table are we making the reference. So this is that f dot flight number, and this is the ticket flights, right? So we can just say tf, so which we haven't applied the alias yet, so we can now say from flights. Okay, and now we just want to perform the inner join, and now we want to say ticket flights, the table name, and then we want to specify the condition over here on, that is the f dot flight id, because that is the primary key. So flight id is equal to ticket flights, we can give this alias of tf, so tf dot flight id. All right, so here we can give the alias as f, okay, for flights. Okay, so sorry, I have just written 2 times over here, so we can just give this alias f. Okay, on f dot flight id equals ticket flights dot flight id. Okay, so now we just want to apply this condition where the tickets are only costing more than 80,000. Okay, so we can just apply the filter condition here. So that is where tf dot amount, since that is coming from ticket flights, right? So we specify tf, okay, as per the schema over here. So ticket flights dot amount, that is should be greater than 80,000. Alright, so let's execute this. So you see that we get all the flights that are having the amount greater than 80,000. So we don't get anything lesser than 80,000. So this is the solution for this first problem. So for the second problem, retrieve all the airports and any flights that are departing from them. So let us first understand which exact tables are concerned within this problem. So one is we have the airports and one is we have the flights. So if we have a look, we just have the airports table, airports underscore data, and then the flights. So in the question they have said any flights that are departing from them, which means that we need to apply left join. Okay, so we can, doesn't matter, you can apply left join or right join, as long as that from which table you are exactly mapping to the other table. So within this airports data, we can return all the airports that it actually contains and also the respective flight. Okay, so if it doesn't have any flight, then it returns null. So that's what left or right join does. Okay, so let us get the airport name first from our airports data. So I'm just going to say select airport name, okay, from airport data. So here we need to see from our schema which is the primary key and which is the foreign key. So you see that airport code is marked as PK, which is the primary key, and the lookup table, that is flights. So we have the departure airport and arrival airport as the foreign key. Okay, so we can just map any one of these. Here we can say left join, that is from flights table. So flights, and we can just give this an alias f. So from the flights table we need the actual the arrival airport, right, or the departure airport, doesn't matter. So you can just copy the key name. So we can just give this from a dot airport name, and we want the departure airport over here. All right, so this is coming from airports data, that is we can give this an alias of a. So now we can just specify our condition on a dot airport code equals f dot departure airport. So since I'm also recording, it's taking some time to query. Okay, so if you are actually executing this, it might not take that much. So here we have the airport name and then the departure airport. Since we have applied the left join, we will be getting all the columns from the airports. Okay, so basically from this table, and we'll only be getting the matching columns from the flights table. Okay, since we have applied the left join. So now we can also verify that by just saying inner join. So this time we are having like 33,000 records. So now if I apply inner join, I should be getting slightly less than that. So mostly they are actually matching. Okay, so that is why. So you can also verify by saying where like f dot departure airport is null. So basically everything is matching. Okay, so I hope you have understood and were able to solve these two challenge questions. So if you are able to solve, then that's great. Okay, so I also want to tell you that you cannot just join just one single table. You can join multiple tables as well. Okay, for example, I have this one single question that is display the passenger name, flight number and amount. So if we have a reference to our schema, so we have the passenger name in somewhere like I just need to check the over here within the tickets table. We just need to join the tickets, ticket flights and the flights table. So we just need to identify which is the primary key, which is the foreign key, the respective table to that, and then we can just do the join. Okay, so we can just start by saying select, that is these three: passenger name, flight number and amount. Okay, so we just need to now like specify the main table, that is from the tickets. So basically we can just start off from the flight number from our tickets table. So over here the ticket number is our primary key, and then the foreign key is over here ticket number from the ticket flights table, and now same over here flight ID is the primary key from flights table, and the corresponding foreign key from the tickets flights table is the flight ID itself. Okay, so now we can just say from tickets okay, and give this alias of t. So we want to get the passenger name, right, from the tickets table, so we say t dot passenger name, and this say f dot flight number, and for the amount that is coming from the ticket flights, so tf dot amount. So now we can specify inner join. So now we want to say from the ticket flights table, so from the ticket flights, okay, give this an alias of tf, and specify our join condition over here. So on t dot ticket number equal to tf dot ticket number, okay, and again we can just do an inner join, this time to the flights table, so flights f, and then specify our condition f dot flight id equal to ticket flights dot flight id. Okay, so I hope this is clear. So now we should be able to get the passenger name, flight number, and the amount. So now if I run this, so we see that we get the passenger name, the flight number, and then the respective amount. Okay, so this is how you can query multiple tables as well. So now let us understand the full outer join. Okay, so basically let's say there's a good question which can appear, that is to retrieve all the flight numbers and the ticket numbers. Okay, just as I explained, so even though there is no matching condition, it will also return even that record. Okay, so now let us perform on that. So let us retrieve all the flight numbers and also the ticket numbers from the ticket flights. Okay, so let us select flight number, so that is f dot flight number, and then the tf dot ticket number. Okay, so first we need to query from the flights, so that is on the left table, so flights f, and now we say full outer join. Okay, and then the reference table, that is ticket flights, okay, giving this alias of tf, and specifying our condition on f dot flight id equals tf dot flight id. Alright, so now we should be able to get all the records that are actually matching. Okay, so we're getting about 1,56,000 records. Okay, so we also need get those records that are even null. For example, I can just put a condition here saying like where like tf or tf dot flight id is null. So you see that I'm getting all the ticket numbers that are null. So we can just do the same for the flight id as well, so where f dot flight id is also null. So basically all the flight IDs were actually matching the flight IDs from the ticket flights table. That is why we are not getting any rows over here. Okay, so this is how you can just perform full outer join. So this is all about SQL joins. All right, so if you haven't understood, you can of course refer the documentation which I have actually linked over here. So that is this one right here. So you can just feel free to have this as a guide. Okay, so in case you don't understand also, you can just let me know in the comments, so I'll just try to answer them as well. So this is all about joins. So let's now move to the next topic. So let us now learn about union and subqueries. Okay, so let us consider this example again of the sale and customer. So if you see in the customers table, we have the city column, right, where every city is assigned to a customer, and also from the sales. Okay, so let's say if I want the cities from both the customers as well as the sales table. Okay, so that is where we need to use the union operator. So whichever the cities that appear in customers and sales, so we just want to return those values. Okay, so how can we do that? So we use the union operator. So as union operator says, combines the results of two or more select statements returning unique rows only. Okay, so basically we just need to select the column from the particular table and then apply the union operator and then select the same column from the next table. Okay, so that is how you can do it. So in case of this example, so we say select city from customers, union city from sales. Okay, so we get results something like this. So New York, Chicago and Boston. So we are getting only 3 values because there are only 3 unique values of these cities. So New York, Chicago and Boston. So there is no any other value. So if we just use union, we only get unique values. Okay, all right, so this is the diagram where you see that these are the rows from table A and these are the rows from table B. So even though they intersect, we are going to get all of the values. Okay, so note that this is not the data from table A, this is the query from table A. Okay, and this is the query and the results returned from table B. Okay, otherwise that would become similar to a full outer join, right? Because there we are querying data from the existing tables, not from queries. But here we are combining the results from two queries, two returned data queries. Okay, so that is how we need to treat union of table A and B. Okay, so I hope this example was clear. So in case we want to also include duplicates, we can use the union all operator. So if we use union all within our example over here, so we get all the duplicates as well. So you see that how many ever cities are appearing in both the tables, we get the results over here. So you see that there are a lot of duplicates. Okay, so this is how this union all works. So here this is just the union of table A and B. You see that there are no duplicates because there are some values intersecting. So when we apply union all, so even though they are intersecting, we get all the values. Okay, even though they are appearing in both the tables. So I hope this is clear. So let us now go ahead and work on an example in our PG admin and demonstrate you a real example. Let us now go ahead and retrieve all the airports that we have within our flights. You see that there are two fields over here. One is the departure airport, one is the arrival airport. Okay, so we can just use the union operator to fetch all the airports that we have. Okay, so over here we have the departure airport and arrival airport. So let's now go ahead and put a union operator. So first let's only select the departure airport. So departure airport. Okay, and also let's apply the union to this arrival airport. Okay, so in between that let's apply the union operator. Okay, so now if I run this, so you see that I'm getting like 104 rows over here. So basically these are all the unique airport names. Okay, so now if I just apply union all, so this is going to fetch all the departure airports irrespective of whether they are there in table A or table B. So you see that this time we are getting 66,000 records. So this is how you can use the union operator. So basically from one query result, so this gives us a result, right? And this also gave us a result. So it's going to combine both of them and then return one. So I hope you know about unions and unions all. So let's now try to solve a challenge. Create a list of all unique codes used in the system, both aircraft codes and airport codes. And the second question is list both scheduled and actual departure timestamps including duplicates for each flight. Okay, so you can just if you have understood union so far, you can just try this on your own. Meanwhile, I'm just going to answer them one by one. So basically we just have the aircraft codes and airport codes, right? So let's go ahead and refer our schema. So from our aircraft's data we have our aircraft code over here, and also from our airports data we have the airport code, right? So we can just apply a union between these two tables. So first we can just query on those two results. So let's say select the aircraft code. So this is coming from aircraft's data. So from aircraft's data. Okay, so let's now do the same for the airport code from the airport's data. So airport code from the airport's data. Okay, so let's check one by one if we are getting the results. So we are getting the aircraft code from the aircraft data and the same for the airport. So now let's apply the union here. Okay, so now you see that we are getting like about 113 aircraft codes. Okay, so basically it says aircraft code. In case you want to change the name, you can just give it an alias of saying just code. Okay, same as here as well. Okay, so now it gets renamed to basically, and I need to put this inside this before from. So now it gets renamed to just code, whatever name we have given. Okay, so this is the first question which we have solved. So this is the next question. List both scheduled and actual departure timestamps including duplicates for each flight. So from the flights table, let me just show you the schema. We have the scheduled departure and the arrival. So we can just mention the flight ID and then the respective times. Okay, so now we can first select flight ID. Okay, and then we can select the scheduled departure. So we can give this an alias of flight time. Okay, just to distinguish between the scheduled and actual departure, giving it a generic name. And then we can select the table from flights. Okay, so the same we can just do for the the actual departure as well. So actual departure, now apply the union all, since they are saying we need to also include duplicates. So union all. Okay, so let's execute this particular query. Okay, so now we see we get the respective flight time for the respective flight ID. Okay, but we don't know whether this actual time is coming from the scheduled departure or actual departure, right? So in such case we can also include the hard-coded string like scheduled. So this is coming from scheduled and this is coming from actual. All right, so we can separate them by a comma and just execute this code. So we see that some are scheduled, some are actually actual. Okay, so maybe it should be in the end. So let's execute only the standalone query right here. So there are some values which are having null, which means that there is no actual departure for that. Okay, so this is the solution for these two. So if you're able to solve, that's great. So now let's move on to the next topic, that is subqueries. So let us now learn about subqueries. Okay, so what is a subquery? So in the name itself it says it's a subquery, which means that it is a query nested inside another query. Okay, so basically there are different types of subqueries where we can use in different clauses, like for example the where, and also we have the from clause and also from the select clause. So we'll go across one by one. Okay, so for example you see that this is a question: find the customers who made purchases above the average sale amount. Okay, so in case if you want to like calculate this, so first we need to calculate the average, and then we'll put in a condition here and where the amount is greater than that actual average amount. So in this example we are getting the customer ID from the sales and putting a condition here where the amount should be the average of some value. So to calculate that average itself, we can just write a subquery. Okay, so we see that the subquery is written in parentheses like this, and over here this actually calculates the average amount from the sales collection, and for every sale it has within the sales collection, it's going to compare the amount and return only those values. Okay, so this is how you write a subquery. So this is just a simple example. So as it says, the innermost subquery finds the average sale amount, so this one which is selected, and the outer query selects the customer with sales greater than that average, this returns. Okay, so this is a diagram which is easy to understand. So if this is our query, this is our subquery. Okay, so basically this one. Okay, so I hope you understood this one. So this is about the where clause. Okay, so we can just go ahead and solve a particular question based on this. So currently we are having this bookings table which has total amount, right? So we can just apply a subquery just to calculate the average of those bookings that are greater than the average. So we can just write a subquery something like this. So we can just put a select, and we can first specify the booking ref and then the total amount. So from this bookings table, book ref and then the total amount from the bookings table. Okay, so here we can just put a condition like where the total amount should be greater than the average, right? So where total amount should be greater than, so as I told, in subquery we need to use parentheses and then write in your query inside that. Okay, so we can just write a query saying select average of this total amount, which is again from the bookings table. All right, so now if I run this, so basically this should be bookings, and here you see that we are getting all those records having the bookings greater than the average amount. So if I just execute this one single query, so this is going to return us the average. So this average is used within our condition here. Okay, so I hope you understood this. So we can only return one single value, we cannot return multiple values. So this is only returning one value, right? So we can, like, for example, if I'm returning multiple values, so this returns multiple values, so this will return all the total amount. So now if I execute this whole query, so you see that it's going to throw us an error, more than one row returned by a subquery. So whenever we are using where, we need to make sure that we are only returning one particular value from this. Okay, so now let us try to solve a challenge question. Okay, so I'm just going to paste that question right here. So the first one is to find the flights that have used the aircraft with the longest range. Okay, and the second one is find the tickets that belong to bookings with a total amount greater than 1000. So if we have a look at the schema over here, So we are having the flights table as well as the bookings table. So before we actually try to solve this, you can just try this on your own. So I'm just going to get started. So first question is like how to finding the flights that are having the aircraft with the longest range. So if we have the look at the aircraft data, so we have the range over here, which is an integer. We need to return all those flights that are having the aircraft data longer, which is having the longest range. Okay, so you see that there is a mapping between the flights and the aircraft data. So let's go ahead and try this. So first we need to select those fields that are required for within our select statement. So I'm just going to say select. So first we need the flight ID, so flight underscore ID, and then we have the flight number, and then we have the aircraft code. So aircraft code is over here, which is going to be a mapping to the aircraft data. Okay, so over here we can just put a where condition. So first let's select the table flights and then put a where. So inside this where we say the aircraft code should be greater than that one particular value, right? So that one particular value is the ID of this aircraft data, which we need to return within our subquery. Okay, so let's say aircraft data, where aircraft's code is equal to this subquery. So we need to calculate the aircrafts which is having the maximum range, right? So first we can just select the data from that table. So select, that is aircraft's code, aircraft data, and over here we just need to order by the range, right? So we get all by descending order, so we can just say order by range. We want this in descending order, so we say DSC. Okay, and then we can just limit this to 1. So by this we only get one value, so limit 1. So in this query we are retrieving the aircraft with the longest range, and this is the condition which we are filtering out. Okay, only those flights that are having with this aircraft code. Okay, so now let's execute this, and this should be aircraft code, and yeah, so there we go, we are getting 610 rows. All right, so here we see that this is the flight number. Okay, so that is PG0000222. So now if I just execute this inner query, so I'll be getting that aircraft code. All right, so this is you could have also done this, right? So which is equal to 773, but this should always be dynamic, right? So we see that we are still getting the same result, so this should be in string. So you see here we still get 610 records. But what if in future there could be some aircraft that is having even longer range than this aircraft over here? So that would become a problem, right? So we just always want to make it dynamic. Okay, so you might have a question like this can also be solved by using joins, right? So that is also fine. So this subqueries is just another way of talking to some other table. Okay, so basically connecting with some other table and getting the results from there. Okay, so you can also use joins, of course. Okay, so this is the example 1. Okay, so let's try to solve the next example. Find the tickets that belong to bookings with a total amount greater than 1000. So here we are having the tickets table and then the bookings table, so which is a mapping of this booking ref. So we just need to retrieve all the tickets that are having a total amount greater than 1000. Okay, so we need to return all the tickets greater than 1000. So let's go ahead and apply the query right here. So first thing, I'm just going to select the required fields, so that is a ticket number and then the passenger name. So select ticket number and passenger name from tickets. All right, so next we can just put a where, and here we just need to bring in the bookings table. So when I apply a subquery that is for the total amount greater than 1000, I will get multiple records, right? But I told you that we should only return one single value, but that's not the case. We can also use in the in operator in order to check the list of values, so if it is actually containing inside that. Okay, so we can just say where book ref, okay, and use the in operator. So inside this we can write our subquery. So in here we can just return multiple values, and it will check for this booking ref if it is there within this particular list. Okay, so here we can just say select, that is booking ref from our bookings table, where total amount is greater than 1000. All right, so here this will return us multiple values just as I execute this. So you see that it has returned multiple values. So there should not be two columns. Okay, always it should be in one column, that it has to apply this condition. So now we can just run our main query, and let's see. So it's going to take a bit of time because this is a nested query, right? So out of like 2,62,000, it's going to make the comparisons. It's going to check from the tickets for every booking ref. So I'm just going to like stop this and put a limit right here. So limit maybe of just 10. So I'm just getting 10 records. So I'm just getting the ticket number and the passenger name who have booked tickets like more than 1,000 rupees. Okay, so this total amount greater than 1,000. So there are a lot many records, so I'll just put a limit right here because we are having a lot of records. So this is all about the subqueries in the where clause. So we have applied subquery in the where clause, right? So there are other clauses as well, like that is from and also select. So let's understand them. So by definition, a subquery in the from clause acts as a temporary table. So let's see an example here. Find the average sales per customer and then list only those that are average above 400. Okay, so here this is the query. You see that in the from clause itself, this acts like a table. So previously within our where clause, we used to put in the absolute table which the data is actually existing, right? But here we just need to return this query, whatever the result it returns. So this acts as a table, and from here we are performing the outer query, that is the customer ID and average amount from this particular query, from this table that it returns. Okay, so I hope you understood this. So this is how you can apply the subquery in the from clause. Okay, so here it says the inner query creates a temporary table, okay, and then the outer query filters the customers with who exceeded a threshold, that is above 400. Okay, so this is just an example. So this is how you can perform like subqueries in the from clause. So now let's go to our database and perform a subquery in the from clause. So let us now consider the bookings table. Let's select like for example the booking ref and the total amount, which are the two main fields we have within our bookings table. So the booking ref and the total amount. So let's select those. So if I execute this, so I get the booking ref and the total amount. So now this is the table which is returned by this. Okay, so I can just use this as a subquery as a table, and then select some particular fields, or let's say I want to calculate the average of this total amount. Okay, so I can just do a select, so basically the average of this total amount, and then we can just say, and then from this particular result table that we get. Okay, so from this particular set of data that is returned. So now if I execute this, so now you see that it is going to return as an average over here, so that is 79,000. So this is how you can this is actually redundant. You can directly calculate the average within this directly within this. So this is just an example which I wanted to show you how you can apply subqueries in the from clause as well. Okay, so basically this acts as a temporary table, and within this we can perform whatever we want. So let us now try to solve a particular question so that you can understand a bit better. So find the average booking amount per passenger. Okay, so when we have a look at our schema, so our passenger is there within our tickets table. So we just need to find the average booking amount per passenger. So we just need to refer even the bookings table. So we just need to apply the subquery in the from clause. So now let's execute our inner query within the from clause. So I'm just going to paste in directly. So we are selecting the book ref and then the average amount. Okay, so from our bookings table, and of course we need to group by the book ref. So group by booking ref. Okay, so now if we see, we are going to get the results grouped by this booking ref. So let's see our data output. Okay, so now this is our inner query. So on this returned result, so we are getting the average total amount, right, per booking. Okay, so basically per passenger has actually made this booking. So in such case, we can just use this as a inner query within our from clause, and then perform the select. So let's select the passenger name. Okay, so that is coming from our tickets table. So from tickets. Okay, so now we just want to perform the join within this result that we get, okay, by this booking ref, since they have a one-to-one mapping right here within this book ref, right here. Okay, so now let's put a join right here. Okay, so here since we are dealing with two tables, we need to give it an alias of this t.passenger names from ticket. So we can just say tickets t. Over here we can just put in our condition here on t.bookref equals the average table. So we can just give this alias as well. So we can just say as like average table. Okay, and we can just say average table dot booking ref. Alright, so now let's run this. So of course for every record it has to compare, right, the average, so that's why it takes time. So we can just stop this and put a limit right here, so limit of maybe 10, and run this. So we see that we are getting all of these passenger names, okay, which are, you know, having a average booking amount. And yeah, we are only getting the passenger name, and I forgot to, you know, also mention the average amount that we are calculating here. So average table dot average amount. All right, so now if I execute this, so I also get the average amount for every passenger. All right, so I know this seems a bit confusing, so let me just explain. This is the table that we are actually returning, okay, as the average table, and from here we are performing the joins from our tickets table. So what does this return? This returns the average amount you know, per booking ref, right? So this booking ref is directly you know, related to this tickets table through this like, you know, mapping, right? So from there we are just performing joins, and then we are calculating we are just, you know, returning the passenger name and then the average amount. Okay, so this is the average booking amount per passenger. So I hope you understood this. So let's now try to solve another question. So this is the question: find each booking's total tickets and show only those with more than one ticket. So this is just an additional condition which you can just in the end apply the where operator. So find each booking's total tickets. So what is the first step is to get the total number of tickets per booking. Okay, so as you see that this is directly linked to the bookings table. So we just need to you know, group by the booking ref and then calculate the total number of tickets for every booking that we have, and then we need to combine the results from the bookings table. Okay, so let's go ahead and do that. So you can just try this on your own if you already know about this. So if you have totally understood, so I'm just going to get started. So the first thing is I'm going to execute the inner query. So the first step is, like, you know, group by the booking ref and calculate the total number of tickets. So I'm just going to say select, first is the booking ref and then the ticket number. So I'm just going to count the ticket number. So whenever we are using count, this is an aggregate function, right? So we always need to group them, right? So ticket number, so that is coming from tickets. All right, so now we can just group by that. So group by and then the book ref. Let's now execute this. So you see that for every booking the total number of ticket is this much. Okay, so now this is our temporary table which we need to join from our bookings table. So let's now you know, get the bookings table. So what are all the fields that we need? So that is the booking ref, of course, and then total amount. All right, from bookings. Okay, we can use the alias of b and we can just say b dot booking ref, and then we join with this table that we have right here. So we say join, okay, with this table on b dot book ref equals the t dot book ref, and we can give this alias of, let's say, t, that is coming from the temporary table. Okay, and then we can just get the the total count. Okay, so we can just give this alias of like ticket count, so as ticket count, and then we can just select that from our main query. So that is coming from t dot ticket number. All right, sorry, ticket count. So now let's finally apply the condition which is more than one ticket. So let's filter out those in the where t dot ticket count which is greater than 1. All right, so I hope you understood this. So this is our this is the result that it actually gave. So we are joining this within the bookings table, so where we are just getting the book ref, total amount, and then the ticket count, which is of course coming from this inner query, and then we are just you know, this should be book ref, and then we are just filtering all those that are having a count greater than 1. All right, so let's now execute this, and this should come from bookings, not booking. Okay, so you see that we are getting all of the bookings which are having a count ticket count more than 1. Okay? So there is no ticket count with 1. Okay, so I hope you understood like how you can apply the subqueries from clause. Okay, so basically we can just do it like this. So this is just an example, so you can just explore some more ideas on this. Okay, so let us learn about subqueries in the select clause. So basically the subquery runs for each row of the outer query and returns a single value per row. Okay, for example, they have told us to display each customer's name along with their total purchase amount. So basically in the outer query, what we are doing, we are just selecting the customer name from the customers, and along with that, within the same select statement, we are also selecting this inner query. So what this inner query says, it is calculating the total amount for that particular customer. So if we execute this for every customer we have, it's also going to return us the average sale amount. Okay, as it says here, for each customer the subquery calculates the total sales amount. All right, so now let us see an example in the pgadmin flights database. So currently I have this bookings table. So what I want to do is, for every booking, how many tickets is associated with it. Okay, so if we have a look at our schema right here, so we are having this one-to-many mapping, right? So from tickets and bookings, so one booking contains multiple tickets, so we just want to calculate how many tickets are there for each booking. Okay, so let's execute that select query. So I'm going to select this booking ref and the total amount from this table. So b.book ref and then the total amount. So here I also want to calculate the number of tickets that are associated with each booking. Okay, so here I can just put a comma. So within the same select, I can just add in a subquery like so. Okay, so here I can just say like select. Basically we have the tickets table. I want to count every ticket with the matching booking ID. Okay, so we can just say select count star, basically count as many tickets are associated for this current booking from tickets, and name this as t. So we can now put a condition where this t dot booking id, sorry, this book ref matches the from the tickets, sorry, the bookings table. So b dot book ref. So now if we execute this, we should also be getting the so it's taking a long time because this for every booking it's making this query, right? So let's limit this to 1 or 10. So now you see that for the associated booking, so these are the tickets that are associated with it. Okay, so this is how you can apply the subquery within the select clause. So let's now try to solve some challenge questions. The first one is show each flight and the number of tickets associated for it. Show each booking along with the total tickets and total revenue. So these are the two questions. So basically we are having the flights table, right? So there is a link between the flights and the tickets table. So if we have a look at the schema, so basically this flights is not directly linked with the tickets, so it is through the ticket flights. So we have this ticket flights table. We want to get for every flight how many tickets are sold. Okay, so from this ticket flights, so the number of ticket flights associated for every flight. Okay, so this is a one-to-many. So first let's select the flight ID and the flight number from the flights table. So select flight ID and then the flight number, f dot flight number. So from flights, all right, let's give this alias of f, and this should be f dot flight ID. So once we have done this, so we can just put in a subquery inside this. So first things, we need to identify what is the mapping key over here. So that is the flight ID, right? So in here, let's say select count star. Okay, so basically we want to count for every ticket that is sold for this respective flight ID. So that is from the ticket flights. Okay, and we can name this as tf, and now we can just put in a where clause. So where and tf dot flight ID, because that is the mapping key, that equals the f dot flight ID. Okay, so now we can just also give this an alias like as tickets sold. All right, so now let's execute this, and of course this keeps on going, so we need to like put in a limit here. Okay, Okay, so this is the drawback of using subqueries like this, because for every element, for every row it has, it performs another nested query. So that is why it takes a lot of time. So that's the downside of using subqueries when it comes to using joins. So now if we see the output, we should be able to get some data. So there we go. So these are the respective flight ID and this is the flight number. So we are having these many tickets that are sold. Right, so this is the solution for the first one. Let's now move to the second one, which is slightly more challenging. So show each booking along with the total tickets and total revenue. Okay, so if we have a look at our schema, these are three different tables that we need to come across. So we have the total tickets, total revenue, and the booking. So here we need to write multiple subqueries because they are asking the total tickets and total revenue. So here we need to apply two subqueries. One is to calculate the total tickets and then the total revenue as well. Okay, so let's first select the required fields. So first I'm going to select the booking ref, which is the mapping key. So select b.bookref. Okay, and then we want two subqueries, so I'm just going to put a placeholder for that, and that is coming from the bookings table. So first thing is we want to count the total tickets associated for every booking. So very simple, we already done that. So that is select, that is count of everything from tickets. Okay, where t dot booking ref, sorry, the book ref equals b dot book ref. Okay, so this is our first subquery, and now within the second subquery we can they are told us to calculate the total revenue. So if we have a look at our schema, the total revenue is within this bookings tables itself. Okay, so for the total revenue, when we have a look at the schema, so that is coming from the ticket flights table. Okay, so these are the three concerned tables which we need to work upon this particular problem. So let's first join the tickets table to the this table, ticket flights. So let's first calculate the amount. So I'm just going to select the sum from the ticket flights amount, so tf dot amount, and now we want to select the table, so that is from ticket flights, and giving this an alias of tf. So now we just want to join with the tickets table, so I'm just going to say join. So you can just say join or inner join, so both means the same. So join with the tickets table and put in the condition, which is a mapping key, that is tf dot ticket number equals the tickets table dot ticket number. So then we can just filter out that booking ref that we are performing this query on. So we can just say where the t dot book ref is equal to the booking ref from the bookings table. So okay, so this is the two subqueries which we have performed over here. So we can just give this alias of let's say for the first one as total tickets. Okay, so for the second one we can just say as total revenue. Okay, so right here, so first thing what we are doing is we are selecting the booking ID, and then we are just performing this first subquery which will calculate the total tickets. So this we have already done before. So for the second subquery, we are taking a look at the total revenues table, sorry, the ticket flights table. So we are just performing the join, and we are just mapping the booking ref. Okay, so by this we can get the total amount. Okay, so from this particular table, this amount. Okay, so now let's execute this query, and of course this is going to take time. Let's limit this to 10. Okay, so I have to only select this. So as you see that for every booking we are getting the total tickets as well, and also the total revenue. Okay, so as you see that this query is not at all performant because we are nesting two more subqueries inside this. So just for fetching 10 records, it took around 15 seconds. Okay, so that's the only drawback of subqueries. So this is about the subqueries using the select. Okay, so I hope you understood and were able to solve these two problems. So now let's move to yet another topic in SQL called as correlated subqueries. So this correlated subquery is dependent on the outer queries row. okay, so it runs again once per row, so it is often used only on select or where. Okay, so for example, so if we consider the customer sales table, find the customers whose total purchase is greater than the average purchase of all customers. Okay, so the thing over here is all customers, so it is dependent on the outer query. The solution is like, first we select the details from the customer table, and here this is the query which actually like maps the customer ID from the sales table. Okay, so from the customers, so here within this where condition, you see that when we are calculating the amount for that particular customer ID, here we are using the customers.customer ID, which is actually dependent on the outer subquery, which actual customer it is actually looking for. Okay, so that should be greater than the average amount, so as per the question. So that is what it says here. The subquery references the customer ID, linking it to the outer query, and then the query actually checks if the customer's total is actually exceeding the average total. That's what they're asking in the question. So this is the example of like correlated subquery, just as I told. So it is dependent on the outer query. So this is just an example. Let's now go ahead and perform this within our database. So let's understand this by an example. Find the flights whose actual arrival was later than the average scheduled arrival time for the same arrival airport. Okay, so I know this sounds a bit confusing. Let me explain. So basically they are telling us to find whose actual arrival, this column right here, some values are null, so was later than the average scheduled arrival time. So this is a timestamp with the time zone. So basically we have this scheduled arrival time, so we need to calculate the average for the same arrival airport. So you see that there are different arrival airports, right? For the same arrival airport, we just need to calculate which are all the flights whose actual arrival, this value is greater than the average of scheduled arrival. This is the example of a correlated subquery, because we are having this condition over here for the same arrival airport. Okay, so that depends on the outer query. So let's now go ahead and select the required fields. So I'm just requiring the flight ID, so f.flight ID, then we have the flight number, then we have the arrival airport, f.arrival, and then we have the actual arrival, so f.actual arrival. Alright, so these are all like coming from the flights table. So now we just want to like calculate the actual arrival, so whose actual arrival was later than something, right? So that comes within the where clause. So where f.actual arrival is greater than the subquery. Okay, so here we just need to like apply that, calculate the average of this scheduled arrival, and then put a condition that it has to be from the same arrival airport. Okay, so let's put a select that is average of this scheduled arrival, so that is avg of this scheduled arrival. So here this actually is we are querying from the same table, but this is a subquery, right? So we can say instead of just f, so that is flights f, which the alias which you are giving, so we can give f2 this time, and then say scheduled arrival, so is again coming from flights table, so from flights, and this time it is f2, since this is a inner subquery, right? So we need to give it a different alias, and now we can just apply the condition where the the arrival airport is the same. So f2 dot arrival airport is same as the arrival airport from the outer query, that is just f. So f dot arrival airport. So now let's execute this, get rid of this equals, and f2 dot scheduled arrival. So actually this does not work, because we just need to convert this to the explicit typecast. This actually extracts the timestamp in milliseconds and then calculates it. Okay, so now if we execute this, we should be able to get the output, and of course since this is a subquery, this takes a lot of time. Let's stop this and limit this to just 10. Okay, so let's now execute this, and there we go. We have the flights whose actual arrival, so that is later than the average scheduled arrival time by this subquery that we had applied, and then these are the respective arrival airports and the flight number. Okay, So this is how you can perform correlated subqueries. So if you ask me like where does this correlated subquery here, so you see that we are mapping this inside this subquery to the outer subquery, that is f.arrival_airport. So that is the outer query. So this becomes a correlated subquery. So let's if you're not understood this, don't worry, we'll solve another question. So let's bring in that. Show all passengers who has paid more than the average fare for the same flight. Okay, so basically let's bring in the same flight table. So from this ticket flights table we are having the amount, right? So that telling us to calculate the passengers who has paid more than the average fare for the same flight. So basically this actually is linked with a flight, right? So for the same flight we just need to find out who show all the passengers who has paid more than the average fare for the same flight. Okay, so basically this again brings in the correlated subquery. So let's first select the required fields. So first we need to make a join to the tickets table. So I'm just going to take the required fields. So first is the passenger name, and then the flight ID, and also the amount. Alright, so that is coming from the tickets table and giving this alias of t, and now we can just join from the ticket flights table. So the ticket number is the mapping key between these two tables. So we can just say on t dot ticket number is equal to from the ticket flights ticket number. So we have the passenger name, flight ID, and the amount, right? So in the question they have asked passengers who have paid more than the average fare for the same flight. So here we can first put a filter here. Here we just want to calculate the amount, so that should be greater than this actual subquery, this correlated subquery. So here we just want to get from the ticket flights table. So we want to calculate the average rate, so that is TF. So since we already marked this as TF, we can mark this as TF2 dot amount from ticket flights 2. Okay, TF2. And again here we just need to filter out that one condition for the same flight where the TF2 dot flight ID is same as the TF dot flight ID. Okay, so this is the solution for this problem. Let's run this, and of course I need to limit certain records. Okay, so maybe just because even I'm recording, so that's why it's slow. So now let's execute this, and there we go. This is the average fare for this particular flight where this particular passenger is paying more than the average. Okay, so this is the subquery. So these are all about the correlated subqueries. I hope you understood by this video. So that is it for this particular section, union and subqueries. So this is just a summary which you can also refer within this, and also you will find this within the description of this video, where you can just access this for free. Alright, so now let's move on to the next section. Now let's learn about SQL managing databases and tables. So far we have learned about data manipulation, that is we have only worked on the available data which is there within our tables, okay, which is there within our database. Okay, so we have used the select command and we haven't used all of these which comes under data manipulation, which we will come in the next section. So basically we have just performed all the queries that we have seen so far. Okay, so this stands for data manipulation language, and there is another command type called as data definition language, which means that this has to be related to creating the database, like managing the structure of the database, creating rules for your database, like the constraints and all of that commands. Okay, so that comes under data definition language, which we will be learning in this section. And there are other command types as well, like the DCL, which is related more towards the permissions. Okay, and also like TCL. So let's start with data definition language. So this is basically all about creating, altering and dropping database tables, okay, and understanding most of the data types. Now you are creating a table, okay, and then applying constraints for it. So all of this stuff comes under the SQL intermediate level. So I decided to include within this particular video of the SQL intermediate. Okay, so let's go ahead and get started. So first thing is we need a database, right, in order to store our data. Okay, and then comes our creating tables. So the first and the foremost step is to create a database, right? So this is the command which you can create a database in two ways. one is using the query tool or the GUI, whichever the tool you're using. For example, in our case we are using the pgadmin. Okay, so it can even be MySQL workbench as well. Okay, so over there you can also create tables using the the GUI. Okay, or you can also create manually using the query tool. All right, so let's open our pgadmin and let's start creating our very first database. So once you log in into pgadmin, you will be currently shown the databases over here. Currently I'm having 4. Okay, so in order to create a database, I can just right click on any one of these databases, or in fact schemas or anywhere. So you can just open your query tool over here. So this will open the query tool for whichever the database that you have selected. So in my case it's the demo. Okay, and over here I can just say the create database and give the name. So I'm just going to call this company DB. Okay, so now if I just execute this, so it is going to create a database for me. So let's wait for it to complete. So you see that it has created a database. Okay, so now if you just refresh this, so you should be able to see 5 databases, right? So this is one way of creating a database. Or in case if you want to like use the GUI, so if you just right click on this, you'll have a drop down for create database, and over here you can just give all of the stuff. Okay, so here you can just give your database name. You can just add some comments if you want, and also if you want you can just assign this to an owner. And there are other settings as well, so which is the encoding first of all, which is UTF-8, which is a standard one. And if you just go to the last, this will give us an alternate command. Okay, so whatever you type this, like for example this is the database name, this is the comment, and this will go ahead and convert this to a SQL command. You see that create database with owner, whichever you have selected, encoding, and this is the comment. Okay, so this will give you an alternate command. So if you would like, you can just copy and paste this within your query tool, and that would create the database with the settings that you have selected. Okay, so this is how you can exactly create a database. So the next step is to connect to a database. Okay, so if you see currently we are still in the demo database, right? So now we just need to connect to this newly created database that is called company DB. So in that case we cannot use the query tool in any case. So we want the the terminal, okay, or the PSQL tool. So basically we are currently in the query tool. So you can just go to any other database apart from company DB in order to connect, and you can just open the PSQL tool over here. So here you can just this is the integrated CLI, which you can play with the SQL whichever you're connected. So currently I'm in demo database, so let's see the command for that. So that is /c and then company DB. So let's paste that command right here. So this is to connect to the database over here. So now we see that you are now connected to the database company DB. Okay, so in order to open the query tool, you can just open your database right here, and within the schemas you can just right click, open the query tool. So now this will open a query tool with the database that is newly created company DB, as you see over here as well. Okay, so this is how you can select a database, or you can switch between databases. So currently I'm in company DB. So if you want, you can just go back to some other DB over here, for example demo. You can just right click and open PSQL tool. So this will be connected to the demo database. Okay, so make sure that you are working on the right database. All right, so this is how you can connect to a database. And if you want, you can list the databases, like for example saying /l, which will list all the databases. In our case we just have it right here, that is 5 databases. You can drop a database as well by saying drop database, the company DB, and this will drop the database. So basically it gets deleted. All right, so this is the major commands when creating or deleting a database. So I can just copy this command, and you need to make sure that you're not in the current database which you're deleting. So you need to go to some other database, and over there we got to delete. Okay, so I'm just going to the demo database and opening the query tool there, and then I can just use the drop command. Okay, so now if I execute this, so this will go ahead and drop the database. Okay, so basically I'm just connected to this database, right? So it's not allowing me to delete it because there are other users that are actually accessing it. So we just got to disconnect this database first, and then we just need to delete that. Okay, so that's only when it is possible. So that's what it's said over here. So you cannot drop a database unless you are connected to. So we just got to switch to another, and then over there we got to delete our database. Okay, so this is the major commands in like creating and deleting databases. So let's now learn about the data types that are majorly used within Postgres. Okay, so basically there are data types that are specially that works on MySQL, and so some data types that will work only in PostgreSQL. Okay, so since we are currently working on pgadmin and Postgres, so we are going to learn all the data types that are defined over here and make sure that some of these commands will not work in MySQL and vice versa, right? So some commands which are used in MySQL will not work in Postgres. Okay, so we need to make sure that we know that. Okay, so the first data type which we are going to learn is the numeric data type. So let's start with the first data type, that is numeric. Okay, so there are various types of numeric data types. So one is the small integer, so which stores a range of like minus 32,000 to plus 32,000. This is usually stored for smaller values, for example the age. Okay, so the age is a good example for the small integer which you can assign the type to. So the age cannot be a large number, right? So you can use a small integer in that case. Okay, so the next type is integer or just int. Okay, so this is just the standard integer. So for example, like you can just assign this to the count column, so where you have a count of this where this is the range. So we're having a very extremely large number, for example counting the population, you can use the big int data type. Okay, so most commonly used is the int. Okay, so where you can use it most of the time. So in case if the value is like 2 less or 2 more, you can just switch between small integer and big int. Okay, so these are the common numeric types, and also we have like the decimal type. Okay, which you can just use this data type saying numeric. One is the precision and then the scale. Okay, so basically this is the exact decimal. So the precision is the numeric value, so that is 10, and then this is the decimal, so how many decimal places it has to go after that point. Okay, so this is how you can use the numeric. So for example, we can assign that to the price. Okay, so the price can have a maximum of 10 and then 2 decimal places after that. Okay, and then we have this double precision. Okay, so which is of course not commonly used. Okay, so this is usually for the floating point numbers. For example, we have the real and then the double, where real holds like about 6 digits and double holds about 15 digits. Okay, this can usually be used for data types like for example rating. Okay, so the rating can just be from like 0 to 5, and up to it can just go up to 15. So if any value goes like up to 15, you can use the double data type. Okay, so this is about numeric data types. Okay, so the next comes is for characters. Okay, so the most commonly used is varchar. Okay, which stands for variable character length, and in here you can just specify up to how many characters it can go. Okay, so as you see over here, up to n characters. So usually you can just give this for name. Okay, so for example name, so you can just say varchar 100. So 100 is the maximum characters which it can use. Okay, so then we have the text, which is actually used for unlimited length. Okay, so basically there is no limit. For example, the description, so it can be how much ever limit it can, because we cannot predict how long will be the description, right? So the good data type to use there is text. Okay, so you might be wondering, why can't I assign text to the name field as well? Because it is not necessary, right? Because it will only assign that much memory to that particular data type, whenever it is necessary. Okay, for example name, so maximum it can go up to is 100, right? So it cannot go more than 100. Nobody will be having a name which is greater than 100 characters. So we are saving resources, we are saving memory in that case, right? Saving storage, right, in that case. So that is where we need to diligently think which data type we need to assign to which column. Okay, so this is how you can decide upon. Next we have is the date and time. So there are various data types related to date and time. So one is we have the date, the time, then we have the timestamp, and then timestamp with time zone. Okay, so for the date we just have just the date only. Okay, for example the date of birth. Okay, and then we have the time, which is only related to the time, for example the login time, for example employee login time. So we can just assign the time data type, and then we have the timestamp over here, which is actually a combination of date and time, basically without the time zone. Okay, so this is the timestamp. Okay, which looks something like this on the screen, and then we have this timestamp with the time zone. Okay, so this contains the date and the time with the time zone. Okay, for example the timestamp can just be like at created at. So whenever we create a document created at, we can just use the timestamp. Okay, so the same, it can even be for updated at. Okay, so the updated at can be with time zone or without time zone. So basically from which country is the database being updated. So in that case you can use the updated at, the timestamp tz data type. Okay, so I hope you understood the data and time. So we'll explore more whenever we are dealing with actual data. And the next we have is the boolean data type. This is of course easy to understand, that is just true, false or null values. Okay, for example, is active, suppose the employee is active or not, so we can just store true or false. Okay, or by default it can also hold null values. Okay, so this is about the boolean data types, which usually stores only true and false values. So the next is we have the JSON data type. Okay, so this is basically store key value pairs, okay, within your database, within that particular cell. So if you want to store the key value pair in that one particular cell itself, so we can use JSON. Okay, so this can hold multiple values, okay, and assign a key to it. So based on that, whichever value you want, you can just access it, okay, in that particular cell itself. Okay, so then we have the array itself, which of course holds multiple values within that. Okay, so basically it can store multiple values of the same data type. Okay, so it cannot be any other data type. Okay, so it depends on the base type. And for example, we have the tags. Okay, so we can just use the data type. For example, it is the text, which is belonging here, and then we can just use an array over here, which means that it can hold multiple values, which is then array of values. Okay, so this is about the array data type. And the last one is the enum. Okay, so which is like not most commonly used, which basically can hold any one of the mentioned values. Okay, so basically like for example, the status, like for the status can either be active or inactive, so it cannot be any other value apart from that. Okay, so enum stands for enumeration, so it can only have one of the mentioned values inside that. Okay, so it cannot hold any other value apart from that. Okay, so this is all about the data types that we have within Postgres. Okay, again, as I told you, this only works, most of them only works for Postgres and not on MySQL and vice versa. So these are all the common data types. So if you have a look at our schema, so within our schema also we have defined certain data types. Okay, so if I just show you that, so we have it right here. So you see that for every column that we have within our schema, we have the data type. Okay, so here it is an integer. Over here we have the character, which only holds a fixed value length over here, so which I haven't also mentioned in that. Okay, so and here we have the character varying, so it can go up to 20 characters. Okay, so these are all the data types which you can of course explore within the schema, and of course the schema is also attached within the description of this video, so you can just explore. So for example, we have the airport name to have the JSON data type, and there are many others. Okay, so and then we have this amount, okay, which is a numeric data type, which can hold up to 10 numbers and 2 decimals after that. So this is a good example where you can just analyze which all data types are actually assigned to each column, and then based on your requirement, so this will be a good practice. Okay, so whichever the best data type you can assign to that particular column. Okay, so this can help you as a guide. All right, and the next section we have is for the constraints. Basically, we just want to apply rules whenever we are actually inserting data or updating data. All right, so basically we also want to like define the rules for your schema, like which table like maps to which table, and what is the primary key, what is the foreign key, which we have already discussed. And so these are all the constraints that you can apply while creating the table. So the first constraint is the primary key. Okay, so which will actually just hold the unique value for every row that we have that it has within the table. For example, this employee ID. Okay, so whenever we are adding a new employee, primary key should actually contain, and that should be the unique identifier within the table. Okay, so that can be marked as a primary key. So this can be integer, or it can be UUID as well. Okay, so basically we can also set this to auto increment, okay, after primary key, which means that whenever we are adding any new employee to the table, so that employee ID will be auto incremented by default. Suppose the last entered employee is like, for example, 10, so the next employee whenever we are adding, that employee ID would become 11. Okay, so that is the auto increment, which is not mentioned over here. So next is we have the foreign key, just as we discussed. So one table can hold relation with another table. For example, the sorry, the customer and sales. Okay, so a customer can purchase, whenever a customer purchases some item, so that can be stored within the sales table with the customer ID only. Okay, so whenever we want to fetch the customer sales, we can just make a join to the foreign table, so through this primary key and the foreign key, and then we can just fetch data from other table as well. So that is where the foreign key actually, so for example, we have within this flights table, the flight ID is the primary key, right? So it actually refers the tickets flights table, so where the foreign key is the flight ID over here. So you see that the flight ID, the column name is same as the column name within the flights table. So this is the foreign key to that. So the primary key and the foreign key must always be the same. Okay, so this is the, so it's marked here as PK, and here it's marked as FK, which stands for foreign key. So the next constraint which we have is not null. So in case we are inserting data that has null values, so in that case it should fail, the insert must fail, which means that that constraint doesn't abide, right? So here it says prevent null values. For example, you can just put a constraint to the name column which has a data type of varchar 50, and we can just, if we say, just say not null, in case it doesn't contain, so the insert operation is going to fail, right? So the next is we have the unique. Okay, so the value must not repeat. For example, the email. So okay, so in order to remove duplicacy, so we can apply the unique constraint to that column. So in case we are trying to add another employee with the same email, so in that case also the operation must fail. Okay, so the next is we have the check. Okay, so we can just put a check. For example, the age, on the age, so if the age is greater than 18, suppose we are having a driving license table, now our candidate data is being entered, so we can just put a check on the age if that is greater than 18. So if it is lesser than 18, then that operation must fail again. Okay, and then we have the default. Okay, so for example, we are adding a employee. Okay, so for every time we don't have to mention the active status to be true. So if you just leave the column as blank, for default, by default it is going to take as true. Okay, so you can just say default true, which means that even if the column is blank, it is going to take the value as true. Okay, so these are all the constraints which we can apply inside Postgres. Okay, so the next step is to start creating tables. Okay, so far we have just created a database, so let's now go ahead and get started by creating tables. Okay, so I'm just going to get started by creating a simple table. So let's go ahead and create a table for the departments. Okay, which will contain two columns over here. One is the department ID. Okay, so here the data type over here is serial. Okay, and not auto increment. So previously I told auto increment, so I just got confused with the MySQL syntax, sorry for that. So we just need to use serial or identity, just as it says over here, and this is actually the primary key. So any table which whenever you construct must have a primary key, okay, which will distinguish the identity of every record. And then we have the department name. Okay, so the data type is varchar of up to 100 characters, and we have applied constraint of not null. Okay, so whenever we add a department, so the department name should be there, and also this has to be unique. So if it finds a duplicate department name already existing, so that will fail. Okay, so this is the how we can create a table. So let's go ahead and copy this, and let's paste that in our query tool. So make sure you're in the company DB database. Okay, so here we can just paste in that command, create table departments, so the column name, department ID, and the name. So let's go ahead and execute this. It says lost connection to the database. Okay, so if you get such message, you can just restart your PG admin and you'll be fine. Okay, so I'm just going to restart this. So now whenever you refresh this schemas over here or the table, so you can find the table over here called departments. Okay, so here you can just see whatever the constraints, the columns are there, and whatever the rules that you have applied. Okay, so including indexes and all that. Okay, so we'll come to indexes later, so it's not important right now. So now we have created a table called departments. So let's go back and create another table, and then later we are going to insert some data manually. All right, so let's go back, and here we are going to create another table called employees, where we have this employee ID. So let me just first copy and paste it right here. We have the employee ID, which is again going to be serially incrementing, and the primary key. So we have the employee name, which should not be null and must hold up to 100 characters. And then we have the age, and here we are having the check, which the age should be greater than 18, for example. And then the salary. Okay, so the salary can be a numeric value, so that is from which can hold up to like 10 digits and 2 decimal places, and by default if we don't provide salary, this is going to be okay. Just for example, okay, this need not have to be real, okay, so this is not real world also, by the way. And then this is the department ID. So basically this department ID refers to the first table that we created using this department underscore ID key, okay. So this will actually be the foreign key, okay. So this department ID is the foreign key, and then the department ID from the departments table is the primary key, right? So this is how it creates a mapping between different tables. And then this is the higher date, okay, so which is of the type date, and by default it is the current date, okay. So this is the table which we can create. So let's go ahead and run this. So you see that query ran successfully, and now if we just refresh our tables, and we should be able to see one for the employees as well, okay. So this is how you can create tables, okay. So if you want to identify your schema, I guess there is a tool over here like schema difference or something. So this will might not sure about this. So when you use, so basically there should be existing a tool which will actually identify a schema for your database, okay. So maybe it's not in here. So now let's start inserting some data manually, okay. So basically we use the insert keyword, okay. So insert into the table name departments, okay. We need to specify the column names within this bracket, okay, by separating a comma between them. So in this case there is just one column over here, and then after that we just need to specify values, and this will be just be a values which you need to specify like this within brackets for every column, okay. So currently we are just having one column, so in one bracket we say finance, which actually links to this particular column name, and then we have the second row that is IT, and then we have the HR, for example, okay. So basically we are creating 3 rows within this departments table, okay. So let's copy this and paste in this data right here. So now you see that this departments this 3 data has been added. So now if you just do a select star from departments, so we should be able to see these 3 rows, okay. So let's execute this, and we see that you see that this department ID was auto incrementing, right? Since we had set the serial, so that's why we get the department ID, department name, and these are the 3 values. So it keeps auto incrementing for every department we had. So now if we just go ahead and add few more things, so it's going to fail because we had applied a constraint that no department should be duplicate. We had applied a unique constraint, right? So that is why this query actually is failing. Let's now go ahead and insert the employees that we have. So basically here we are having 4 columns: the name, age, salary, and department. And after that we need to specify values, and then we need to mention in the same order that the column names are mentioned over here. So for example, the name, so the first one is the name, then the age, then here is the age, salary, and then the department ID, okay. So this is how you can insert data, okay. So make sure that the ordering is right, okay. We have name, age, salary, department, name, age, salary, and then the department, okay. So we are going to insert 3 rows over here, and then if we just execute this, so you see that our query is executed. So now let's select all from employees. Should be able to see 3 employees, okay. So basically they are having a department ID. This actually refers to the department where they are actually working, okay. So this is how you can insert data into the table like this, okay. And this is about inserting data. So this is about updating and deleting, okay. Suppose if I want to update some particular record in the database, okay. So for example, this particular employee got a hike, so I want to update the salary data. So here we can just say update employees, set salary to the respective amount where the employee ID is 1, okay. So this is the syntax whenever we want to update any kind of data. So now let's paste that right here. First we want to specify which table are we making the update, that is the employees table, and then we want to use the set keyword and then specify the column name, that is the salary, and the updated value, that is 70,000, and we just want to provide the unique value where the employee ID is 1, okay. So if you see the employee ID, so the employee is Alice, okay. So currently it is 50,000. Now we want to update that to 70,000. So now if we execute this, so now if we just query back the employees collection, so now we should see Alice over here with the salary 70,000, which is actually updated. Okay, so this is how you can update columns. Okay, so the basic workflow is select the table name, then set the column name to that particular value, and then for which particular row are we actually updating. Okay, so if you don't specify the row, so it's going to update all the records that it has. Okay, so we need to make sure that we are having this. And yeah, so this is about how we can update a record in SQL. So we can also delete rows. Okay, so we can just say delete from employees where employee ID is 3. Very simple. So let's go ahead and execute this right here. So if we just play this and now select everything from our employees, so we should see that the employee ID 3 is not there. Okay, so this is how you can delete data or delete rows. So we have learned about selecting, updating, inserting, deleting. Okay, so merge and lock are not that very important, so that comes under advanced. Okay, so let's go ahead and implement other DDL commands. Okay, like the alter, drop, truncate, and rename. So that only applies up to the table level and not in the data level. Okay, so we have the first thing is the alter command, which actually alters the particular structure of the table. Okay, so for example, we want to modify the constraint, or we want to change the data type, or we want to add another column, so we use the alter keyword over here. Okay, so in this example, we have the alter table employees. Here we just want to add a column called as email, and then this is the data type, and this should be unique. Okay, so previously we didn't have a email column, so we just want to add that to the employees. Okay, so let's go back and just paste that command right here. Alter table, we need to select the employees table, we need to add a column called as email, provide the data type for it, and then the constraint. Okay, so we need to make sure that this steps are very clear in your mind. First is the selecting the table, and then selecting the column or adding the column in this case, then add the data type and then the constraint. So the table, the column, data type, and constraint. Okay, so whenever you are working with SQL. Okay, so let's execute this, and I had to execute the whole query. So now we see that it has added another column called as email within our employees. So now if I just select all the employees, so now you see that we are having email. So currently it is storing as null because previously we didn't have the email column. So for all the existing rows, it's going to just enter as null. Okay, so this is how you can add a extra column by using the alter command. And then we have the modify column type. Basically, if you want to modify the type of the column, for example, to say numeric. Okay, so previously it was 10, so now we just want to update this to 12. So again, as I told you, first we select the table and then we alter the column, okay, the salary, and then we just want to modify the type, the data type, numeric, to be this one. Okay, so let's execute this one. Okay, so previously the type was numeric, now we just want to update this to 12. So let's execute this. So now we got this updated. So now if we just try to query this, so we should have the salary updated to 12 and then 2 decimal places. Okay, 12 digits and 2 decimal places. So this is how you can alter the column types as well. So here we just say alter column and then your column name, then specify the type keyword. So what we want to alter, that is the type, so we just set the type to numeric and then this one. Okay, so this is how you can alter something, alter type of a column. And the next we have is the drop column, where we say alter table employees and then we say drop column and then the column name. Okay, so it's very simple. Okay, so it's actually almost readable like in English language. So alter table, the table name, drop column, email. Okay, so it's very intuitive for any SQL developer, right? So we can just paste in that here now, and now we should not be having the email, okay, within the employees. So now if I execute this, the email column is gone. Okay, so this is how you can use this. So basically the drop and then the column email. Okay, so these are all the keywords which we actually don't have to even memorize this. Okay, so you can just use this as a guide. So in case you are building a SQL project, in that case you can refer the docs. Okay, so you don't have to memorize this every time. Okay, so the next thing is how you can rename a column. So again we say alter table employees and then we use the rename keyword, column, then the name column to, let's say, full name. Okay, so let's copy this, execute this. So now we should be having the name column rename to full name, just as you see over here. Okay, so this is how you can rename a column, and also you can rename a table as well. So we say alter table employees, and then we rename that to, let's say, staff. Okay, so let's copy this, execute this. So now if I re-execute the same table, so we should be getting an error over here. Okay, so this employees table doesn't exist because we had actually renamed this, okay, to staff. So we say staff, and now if we execute this, so now we see that we are getting the data since we had renamed this. Okay, so this is how you can rename table as well. So this is fully flexible, so you can just modify the command however you want, okay, based on your use case. So this is just an example which I'm telling you. Okay, so once you have mastered this example, so you can just build any kind of structure of your SQL database. Okay, so and then we have the truncate and drop. Okay, so these are all the data deletion commands. Okay, so basically truncate is basically to empty all of your the table data. Okay, so basically it says remove all rows, but it only keeps the structure, it keeps the constraints, it keeps the columns as it is, and also the data types. So there will be no change in all them. Only thing is that the data will be, all the rows will be deleted. So if I apply that to the employees, so I'm just going to rename this back to employees. So now let's say truncate table and then the employees. Okay, so let's execute this, and we should able to see all of our employees table been deleted. Okay, so now if we just do a select star from employees, okay, so now we should be having no data in here. Okay, so we don't have any data right here. So this is how you can just remove all the rows within the existing table without actually modifying the table structure and all. And then we can just remove the entire table by saying drop table and then the employees. Okay, so let's execute this. Okay, so now our table is being dropped. Okay, so now if we just do a select star from employees as well, so we should be getting a table not exist error. Okay, so this is how you can use all of these commands in order to play with your tables. Okay, so using the DDL, so that is data definition language. So this is all about it. So these are all the most common metadata commands which you can execute in the PSQL tool or the CLI, the SQL CLI, Postgres, which I mean. So this is about to list the database, this is to connect to a database, these are to list all the tables within your database, and this is the command to show the table structure, okay, with all your constraints and your data types. And then we have the show the current DB, so we say select the current database, and this will show your database. Okay, so these are all the, I guess, everything which I had to tell you. Okay, so this is just the basic workflow. Whenever you are building a SQL project, first you create the database and then create tables applying all the data types and constraints. Okay, so we, after creating tables, we insert data, okay, in this format, and then we start querying data. Okay, so these are all the steps. First is create database, tables, then insert, and then if in case you want to update anything, you can update, and then we can just start querying. Okay, so this is all about this particular section. So you can just practice this on your own. Just try to create a database and then start inserting data, create tables, apply constraints and all that in order to master all the DDL stuff. Okay, that is data definition language. So you can just have this as a guide. So I'll be attaching this to the description of this video as well, so you can just seamlessly navigate through this guide. Okay, so this is just the summary which you can actually refer. So that is it for this video, guys, about this SQL intermediate level. Okay, so in the next video I'm going to get the advanced level of SQL. Okay, so we are going to discuss some more stuff. Okay, so I'll see you guys in the part 3 of this SQL series, which is advanced. Okay, so make sure you subscribe and stay tuned for part 3.